Hello viewers, welcome back to our channel. Today let us talk about power series solution chapter 5 of differential equations. But thank you for watching, subscribing and sharing. I think you are gaining from these videos we are making. Today let us see on cases where we have to combine we say we can combine series with the interval of convergence using the same interval of convergence using the following operations. Now we shall always combine power series when they have the same power, they are all the same power n, and then when they all have the same starting point. I'm repeating it again. We shall always combine power series when they are all of the same power, x power n, and then here x power n, something power n here, and then when they all have the same starting point. I.e., if our power series 1 equals from x equals to from summation from n equals to 0 up to infinity of an into x minus x naught power n, then plus or minus summation from n equals to 0 up to infinity bn x minus x naught power n should be the same as having, we just put them together, summation from, so this is x minus x naught power n. I'm just putting them together. It is an, which is this one here, minus or plus bn, which is here. Remember, this x minus x naught is the same. Just put it here outside, just like that. Now, the note from here is that when the power series not have the same power and not have the same starting point, we shall not always combine them. What we have to do is for us to first make them have the same power. After them having the same power, then you have to make them have the same starting point by either moving the power series forward or moving the power series forward to the highest starting point. We shall see now next videos. Now next videos. Now if you have a power series like this, we have something outside and then we want to put it out inside. You have a power series a into x minus x naught power k, then you have to put all of this inside the power series, because this summation sign is just commutative, can come up or can come back or comes inside without affecting anything. Therefore, this is the same thing of having a times an. Now summation from n equals to 0 to infinity. Now this x minus x naught is the same as this one, then just add the powers, then n plus k. And then if I have my power series, they are equating themselves, that an summation from n equals to 0 to infinity of an into x minus x naught equals to summation from n equals to infinity bn minus x naught power n. This means that these coefficients of the power series an and bn are equal for all x in the given interval, x minus x naught less than r. And then if our power series equals to 0, therefore the all coefficients are only going to 0. Therefore, shall just compare them with the 0 coefficients that are assigned. I think for that case we can. I may just take you through on how we either make the power series have the same power because this one is crucial. Shall always use it. All these 4 steps operation I've told you, we shall need them when you are solving the power series solution solving differential using power series solution. But most importantly, I want to show you how we do this. How we can put different power series which have different powers to the same power, and the same way how we can put different power series which have different starting point, the same starting point. Now from there, allow me to take you through on how we can put different power series with different powers, the same power. Now from there, if I put off this now, because these rules you just need to know them in head, because you have to apply them. Now let us take an example. We are given a power series. It is example. Let's take an example 1. We have a power series summation from n equals to 0 up to infinity an x minus x naught power n. Now they want us to take this power series up to n. I want now the starting point of this power series to be n plus 2. Take an example. We had power series, different power series, but other power series had n plus 2 somewhere. Then let us take this power series to become n plus 2 also. What do I have to do? I just say when n is 0, I put then n is 0 in this format. This is the same as having, I'm saying that if I put in n, when n is 0 inside here, I'll have a0, then x minus x naught power 0, which is the same as 1. If I have a naught, now plus. Now I put now when n is 1, I'll have a1, now x minus x naught power 1. Are we together? Now plus when a is 2. But now, just remember, I just want it to come from 2. Yeah, but say from 2 to infinity. Same as having plus summation from n equals to 2 up to infinity of now an x minus x naught power n. Just like that. While we together, I'm showing you how we shift a power series which has a lower starting point to a higher starting point. We just give it its value. Say when n is 0, then first get values when n is 0. A0 into x minus naught power 0 is going to be a naught, which is here. Now when n is 1, remember we shall use when different values of n. I have when n is 0 plus when n is 1 plus when n is 2, then up to infinity. Now I bring when n is 0. When n is 0, I have a naught. Then when n is 1, I put it when n is 1, I have a1 into x minus x naught power 1, which is this one here. Now beginning now from n is 2 up to infinity. I just now submit from n equals to 2 up to infinity of this series. Now I think I have shifted from n equals to 0 up to n up to when n equals to 2 now. I think we are going on that step. We shall see more examples in calculating a power series, how we apply them. Now another case we need to know here is for us to put a power series to the same to x power n. Remember, we shall always need to have our power series to x power n, and then we shall always need to have our power series with the same starting point. Now take an example. If you are given something like summation from n equals to 1 infinity, then n into an. I'm just giving you just random examples, but we shall see how we apply them in just our easier way. Now we may be having a certain differential equation, a certain power series like this, a certain series like this. Now remember, we say that we shall always need to have x minus x naught power n, not power n minus 1, as our first step. Now here, for us to put x power n minus 1, to make this one n minus 1, I'll have to add plus 1 where there is n, to make this one plus 1. Therefore, I'll have something like the same thing as having summation now from n. Now from where there is n, I add plus 1 because I want to make this one n. I have n plus 1 equal to 1 infinity. Now n plus 1 into now n plus 1 together now x minus x naught into n minus 1 plus 1. This is the same as having summation from n equals to, now if it comes in, it's going to be 0, n infinity, n plus 1, now an plus 1, now x minus x naught power n. I have brought my power series to the same power as n, the same power n. Remember, we said that we shall always need to put the power series, the power n, x minus x naught, the power n. Therefore, how do I do it? If I have n plus n minus 2 here, I have to make it an n by adding a 1 on n. Therefore, where is n? I keep on adding 1. Then I'll add n here on n. I'll add 1 here on n. Then I'll add 1 here on n, and then I'll add here 1 on n. Then I'll have my power series as this one. Yes, the last example we can do here is for us to. Here, let me just give you another classical example. We may have summation from x equals to 0 up to infinity now of 3 n plus 2, now an minus 2 x power n, just like that. How do you see that one? We have that simple example like that. Sorry. The example is like this: 3 into n plus 2 an, then x power n plus 1 plus 2. I'm told to make, remember I have to first make this x minus x naught power a, not n plus 2. Now how do I do this one? I subtract where there is n. I move there, I move minus 2 where there is n. This is the same thing as having summation from n. Same thing as having summation from n. Now where there is n, I put minus 2. n minus 2 equals to 0 up to infinity. Now it's 3 into n, this is plus 4, this is not 2. Plus 4, then it's n plus 4 minus 2. Now n minus 2. Now x into n plus 2 minus 2. The same thing as having summation from n equals to 2. Now come inside infinity now. 3 into n plus 2. Yes. N into n minus 2, then x power n. That's like that. Shall always need for us to put a series to a given, shall always need to have our series with the same power n and then have the same starting point. I think with that we can stop from here, and then we shall see more examples on how we put the power series the same power and then have the same starting point. Thank you for watching. Like, share, subscribe, and comment for more videos like this.